Welcome everyone. Today I'm going to continue my synthesis of TCPO. We have already made phenol from salicylic acid before, we already have made phosphorus pentachloride, and today we are going to make anhydrous oxalic acid. I only have oxalic acid dihydrate and we need the anhydrous form because we wouldn't be able to convert it to oxalic chloride otherwise. Methods like refluxing with toluene and using a Dean Stark apparatus have been covered on YouTube before. I don't have a Dean Stark apparatus, so I'm going to use a completely different method. Enjoy! We're not doing a preparation today, but chemicals are still required. We're using oxalic acid dihydrate and anhydrous calcium chloride as a drying agent. Without the following piece of glassware, the drying process wouldn't be possible. This is a drying pistol. You can see it has a flask on the left and this weird piece of glass on the right. Vapors, we are using water vapor, travel to the outer part of the tube and heat up the inner parts to whatever temperature the solvent boils at. Using a condenser, they are condensed and flow back into the boiling flask. The drying pistol was weighed out in advance and I then just added as much oxalic acid dihydrate as I wanted. It was weighed again afterwards. The only reason we are weighing it is to determine if we actually got an anhydrous product. Anhydrous calcium chloride was added to the other flask. Because a vacuum will be applied, we applied a generous amount of grease to all joints. By using enough grease, you can perfectly seal it and therefore you don't have to readjust the vacuum. As a heating medium for the drying pistol, distilled water will be used. Normal water could also be used, but by using distilled water, I don't have to rinse the flask with distilled water afterwards. Heating and stirring were turned on and now you can take a look at the apparatus. At the bottom we have the boiling flask, here we have the drying pistol with its mantle, and at the top we have a condenser. Before we can begin, we must apply a vacuum to the apparatus. A vacuum pump was attached to the flask and it was completely evacuated. Vacuum lowers the boiling point of all sorts of liquids. In our case it's the water and oxalic acid dihydrate. The water in the mantle of the drying pistol has a temperature of 100 degrees C. Therefore we must lower the boiling point of the water in the apparatus. As you can see, I also don't have one of these plastic clips to connect the flask to the drying pistol. Therefore, the vacuum also helps to hold the flask in place. The heat of the heating mantle was cranked up to max, and now I'm going to explain to you this apparatus. We have the boiling flask, the vapors travel upwards through this mantle. Whatever's in there will be heated up to the boiling point of the solvent, and the vapor travels up here. Here it is condensed, flows back down, and goes through this small tube back into the boiling flask, and the process is repeated. The flask was wrapped in aluminium foil and here you can see the drying pistol in action. The water and the oxalic acid will evaporate off and in theory it should be sucked up completely by the drying agent. Of course this wasn't the case and some of it also just condensed on the walls of the receiving flask. The boiling water was allowed to do its job for 90 minutes. Occasionally fresh vacuum was applied, but we did not have to do this because the vacuum was still completely intact. Once the 90 minutes had passed, heating and stirring were turned off and we waited for the apparatus to cool down a little. A very crude measurement to test if the drying process is complete is to touch the receiving flask. If it's cold, the drying process is complete. The reason that it is cold once the process is complete is that because no new hot water vapor is generated and therefore the flask can't stay hot. After flushing the apparatus with air, the receiving flask was disconnected. To keep moisture from entering too early before I could weigh it, the opening was covered with aluminium foil. The contents were transferred to a pre-weighed flask that can be sealed to keep all moisture out of it. We started with exactly 59 grams of oxalic acid dihydrate and ended up with 43.8 grams of dry oxalic acid. In theory, we should have ended up with 42.1 grams of anhydrous oxalic acid. It could either be that it still contains some water, or that it is anhydrous but contained a little more water in the beginning. I'm just going to assume it's anhydrous for making TCPO. There's only one thing left to do, which is to slap on a nice label, and we're finished with step 3 out of many for making TCPO. If you liked today's video, make sure to drop me a like. If you don't want to miss out on further chemistry content like that, make sure to subscribe. I have to thank all of my Patreon supporters, because without you this wouldn't be possible. If you want to become a Patreon too, because these videos aren't cheap to make sure to check the link in the description. Anyways, I wish all of you a great day. We will see each other in the next video.